Hello guys, so today's problem of the day in Leetcode is number of sub-arrays with odd sum. Okay, so what the question is saying that we have given an array of integer okay, ARR or integers. Basically we have given an array of integers. We have to return the number of sub-arrays with an odd sum. Okay, so here's the one thing, that since the answer can be very large, return it modulo. Okay, so we will just see later. So let's see what the question is just saying. Let's see, go on the direct explanation. Okay, so I have taken this example 135. Okay, so what we have to do is we have to just form first, basically we have to just return the total number of basically sub arrays with an odd sum. Okay, so let's just first thing let's just calculate all the sub arrays of this 135. Okay, so all the sub arrays I have written 1, 1, 3, 1, 3, 5, 3, 3, 5, 5. I've just what is sub array? Sub array is the contiguous basically integers in array. Okay, so these are total sub arrays that can be formed with this array. Okay, and so if we calculate the sum of these total sub arrays, that is 1, 1, 1, 3, 4, 1, 3, 5, 9, and total it is sum. So you can simply return what the total number of sub arrays with odd sum. So how many there are odd sum? That is simply here 1, 9, 3, 5. That is total 4. So simply we would return 4. Okay, so that's here output is also 4. Okay, so here's the explanation also that I have explained the question. Okay, so total number of odd sum are in the sub array is 4. So you just got the basically main crux of the question, that is what the question is saying and what you want, what you have to do. Let's just say how we can do that. Okay, if we see the brute force, what would the brute force simply? Brute force will simply be like if we iterate through here, that is I. Okay, and from here at j. Okay, then we will simply iterate through all the possible sub arrays. We will form all the possible sub arrays. Okay, from here to here, and then from I to here, and then for j. Okay, we will simply form all the sub arrays and we will simply add them. Okay, and every time we will check if the add, basically if the sum of is the even or odd. If the sum is even, we will just update the count. Okay, so simply if we say that the values could be simply very large. Okay, so it will simply give TLE. Okay, what TL is? Time limit exceed. Okay, so it will simply give it time limit. Okay, so that's why the brute force will not work here. But you got the thing that how brute force can be formed. We could simply use to basically I and j variable, and we could simply iterate through and will sum all the possible sub arrays, and we'll check every time if the sub array sum is basically equals to the basically is even or odd. Then if it is odd, then we will simply I basically append the, or you can say increment the value of count. Okay, we will take a variable count. So you got the brute force solution. It will simply give TLE. Okay, it will simply take so much time. So let's just move on the main approach or efficient approach. So the efficient approach we are using here is PrefixSum. Okay, PrefixSum. How we will use PrefixSum? Let's see. Okay, on the approach. Okay, so I have written this array as example. That is basically example I have taken here also. So I have written the PrefixSum of this array. Okay, so let's see. You basically, what is PrefixSum? It is the cumulative addition of just addition of the basically whole numbers in the array till the index where we are. Okay, so simply if I say that if I is here, then simply it is the sum till I here. So see the sum is 1 because I is at the first. If the I is at here, then it is the sum of till this 3. So 1 plus 3 is 4. If I is here, okay, let's just move. If I is here, then simply it is the sum till 5. All the numbers of the array till 5. So simply it will 1, 3, 5, it gives 9. So simply the PrefixSum array would be 1, 4, 9. if we let's just make some calculate some basically things that how we are basically gonna approach this. If you choose two prefix sums, okay, let's just choose two prefix sum, that is these two, let's just take, okay, let's just these two, okay, this and this. If we calculate, I will just tell you one thing, that if we basically let's just calculate, okay, 9 first we will calculate the difference, okay, prefix sum, let's just calculate the difference. 9 minus 4 would simply give 5, okay, simply would give 5. So if you see that when if I take the two like variable, that is I here and the j here, okay, j here. So if you see that wherever I minus j, we are doing I minus j, the number at prefix sum I minus prefix sum j, the value is given, that is array of basically I, that is 5, okay. And if we take any two, okay, this let's take this, okay, so it will simply I minus j would simply give 4 minus 1 would give simply 3, and here also it is simply giving 3, okay, here. So if we minus just this with this I minus j, see 9 minus 1, okay, okay, 8. So if we see that whenever we subtract the two prefix sum, it is simply giving the sum of the sub arrays, like here first we have subtracted the 9 minus 4, that is here, so simply it gives the sum of the sub array at this last, okay, that if basically if we take here only if we see I and j, the here only the one sub array is, that is 5, okay, and simply when we subtracted this from I to j, it is simply giving the sub array sum of 3 and 5, okay, simply from j to I, okay. So these two numbers 4 and 9 for 3 or 5, okay, last two numbers. So we can simply say one thing we can see here, that is if the two digit are basically if we just take this, let's just take this also, you will understand a little bit more with this. Let's just take the sum also, so that understanding could be more, okay. So let's see, okay, so when we are subtracting, okay, when we are subtracting that 9 minus 4 is giving 5, that is basically odd sum, okay, that we have to return, okay. And when we are subtracting 4 minus 1 3, that is also giving odd sum, okay. And we are subtracting 9 minus 1, that is 8, that is giving basically even sum, and we don't have to return the count of this, okay. So if we see that whenever we subtract odd, okay, odd minus even, okay, it simply gives odd sum, okay. And when same for this like even minus odd, okay, simply it gives odd, okay. And whenever the both values are odd, that is odd minus odd, it simply gives even, and the same for this even minus even, it simply gives even, okay. So this is the thing that we have taken from this prefix sum approach, okay. So this is the main thing, okay. So this is the approach what we are going to is, that is odd even parity, okay. So let's just move on the approach and how we will basically do. Let's just dry run the code, okay. So let's just take this, okay, and let's just take this also, okay. So let's just copy it, okay. So what we are going to do is, okay, we will first calculate the prefix sums. Okay, prefix sum. Okay, and we will take care of the odd, basically odd sub arrays. Okay, odd count you can say, or odd count, and we will take care the basically even count. I will tell you what is this. Basically, prefix sum is the prefix sum array that will simply it will create. Okay, not array, it will simply generate the prefix sums. Okay, and odd count, basically odd count would be the previous count. Basically, it will simply odd count is the number of sub arrays with odd sum. Okay, and even count is number of sub arrays with even sum. Okay, you got the thing. Okay, so what we will do is we will simply iterate through this 135. That is, if we iterate through, let's just make what we'll do 1. Okay, so simply start from 1. Okay, the prefix sum would be simply, what will the prefix sum? It will simply be 1 till here, and at initial the odd count. Okay, the odd count, what would be the odd count? Let's see. At initial, let's just first initialize it. Okay, it will simply be 0. Okay, and even count, what will the even count? If it will be simply 1. Why 1? Why not 0? Because if we say that if there is no basically sub array, then it will simply give 0. So 0 is also a even. Okay, so simply the even count value would be 1. So prefix sum, let's start from here. That is I. That is, prefix sum would be 1, and the even count, it is simply even. Simply the odd count will be, well, sorry, the sum is basically 1, and the odd count would be 1 because its sum is odd. Then simply we will move this I to next, that is 4, and prefix sum would be simply plus 3, that will be simply 4. Okay, and the sum is basically what? Sum is even, so simply the even count would be 2. Okay, then we will move, okay, 5. Okay, and then odd count till here. If we see prefix sum is, let's just calculate 4 plus 5 equals to 9. So the odd count will be simply 2. Let's just plus 2. Okay, so the odd count will be simply 2. Okay, so because the sum is here 9. Okay, so one thing we have to do is that every time, okay, we will take a variable also, that is count. It will simply give the total number of odd sub arrays. Okay, so what we will do, basically at every time, just let's see, like if we have calculated the odd count and even count, so for every time we will take this count variable and we will add, whenever we basically encounter the even count, we will simply add the previously odd count. That is, let's see first, okay, let's just write here. Okay, like here, whenever we encounter even count, we will simply add them the previous odd count that we have seen. Okay, and whenever we encounter odd count, okay, we will simply add the previous even count. Okay, total even count that we have seen. Okay, basically even count is even the sub arrays with even sum. Okay, count plus even sub array. Even count. Okay, variable was even count. Okay, so let's see again. Okay, so the odd count will be 0, even count will be 1, and count this time whenever we encounter odd, basically sum of the sub arrays, they will simply add the total basically previously even, and whenever we basically encounter the even, we will simply add the previous odd. Okay, so first I will be here, prefix would be 1. Okay, so simply it is odd, then simply add the 1 to odd count, and previously we will simply count, update the count, that is previously even count was 1, then simply count would be 1, and then we will move this I to here, that is on 3. Prefix sum would be simply 4 plus 3, that will simply be 4, and here the basically sum is even, then simply it will append the even count, and the count will be simply appended with previous count, that was 1, and the previous odd count, that was 1, then simply it will give 2. And basically the next what we'll do, we'll simply move this I to here, and the sum would be simply plus 5 equals to 9. Okay, and the odd count would be simply be increased because the sum is odd, and we will simply append this count. What count was 2, okay, and the even count was also basically 2, so it will simply 2 plus 2, 4. Okay, so the iteration would be end. Okay, iteration would end, and the answer would be simply return count is 4. So we will at last we will return count. Okay, so you got the thing that how we have done. I will tell you in the Leetcode also, and I will provide you the code also. Okay, so let's just see here the basically the code in Leetcode. Okay, so what we will do first at basically int, we will take even count, that will simply take care of the even basically sum of sub arrays. Okay, that will simply be 1 at first, and then odd count will simply be 0, and then count, that will simply give total number of odd count. Okay, the answer that will simply be 0. So let's check the loop or int num and in array, then simply it will simply give what we'll do, we'll calculate the prefix sum equals to plus equals to num. Okay, and I have not taken the variable prefix count. Okay, let's just take int prefix equals to 0. Okay, so what then after we will do, we will check if prefix sum %2, that is if it is even or odd, equals to 0, then simply we will say that what will say that we will append not we will first we will calculate the count will be simply count plus equals to the previous odd sum. Okay, so odd count. Okay, then at else it will simply if the sum is odd. Okay, so simply what we'll do, we will simply calculate the count plus equals to even count. Okay, and I have not written the basically here the even count will be plus plus, and here also odd count will be plus plus. Okay, let's just correct this spelling. Okay, so at last what we'll do, we will simply calculate every time count %. Okay, so simply at last return count. Okay, so why mod? Because we have to simply return the small value, not large. So let's just run it. What it has returned that count. Okay, I have written this wrong spell. Just try it. Okay, one thing I have mistaken that. Okay, I have not taken the mod of it. I have mistaken 1e9 plus 7. Okay, so let's see. Now this time we're going to have something. Okay, yeah, let's try. Let's submit it. Okay, so yeah, that's fine.